When sunlight filters through the parchment scrolls of the Library of Alexandria, a scholar bends over his desk, his quill pen sketching straight lines and regular figures on the paper. This is Euclid, the culmination of ancient Greek geometry, known as the father of geometry, unlike Archimedes, who left a bold declaration of moving the earth, or Pythagoras, who intertwined mathematics with mysticism. He used elements as a key to open the door for humanity to understand the order of the universe. From the academic halls of ancient Greece to the modern mathematics classroom, Euclid tells the eternal pursuit of rationality and order through every axiom, every theorem, and every logical deduction. Little is recorded about Euclid's life, but his active trajectory is closely linked to the golden age of ancient Greek civilization. He lived roughly from 325 BC to 265 BC, mainly engaging in academic research and teaching in Alexandria, Egypt. At that time, Alexandria rose to prominence due to Alexander the Great's conquests. Becoming an academic hub of the Mediterranean region, the Library of Alexandria, in particular, gathered books and scholars from around the world, providing fertile ground for Euclid's research. There is no clear historical record of Euclid's academic lineage, but judging from his academic ideas, he was deeply influenced by the Pythagorean school and the Platonic school. The Pythagorean school's emphasis on mathematics and research on geometric figures provided Euclid with a wealth of mathematical materials. Plato's view that mathematics is a tool for understanding the world of ideas further shaped his academic pursuit of constructing a knowledge system through logic. In Alexandria, Euclid founded his own mathematical school, attracting many disciples, including later scholars and nobles. It is said that Ptolemy, the king of Egypt, once asked him, "Is there a shortcut to learning geometry?" Euclid left the famous reply that has been passed down through the ages. There is no royal road to geometry. Although Euclid's personal life is shrouded in mystery, his academic achievements have shone like a beacon, illuminating the path of mathematics for future generations. He was not the original creator of all geometric knowledge, but he systematically organized scattered geometric propositions with rigorous logic, constructing the first complete mathematical axiom system in human history. This wisdom allowed him to transcend his era and become an eternal scientific symbol. Euclid's greatest contribution was the compilation of elements. This work, consisting of 13 volumes, covers plane geometry, solid geometry, number theory, and other fields, with a logical structure of axioms, postulates theorems. It organizes mathematical knowledge from ancient Greece into a rigorous academic edifice, becoming one of the most widely circulated and influential scientific works in human history. Euclid's greatness lies not only in organizing geometric knowledge, but also in the scientific ideas he proposed using logic as a tool, taking axioms as a starting point, and pursuing the certainty and systematicness of knowledge. This idea laid the methodological foundation for future scientific research. Before Euclid, mathematical research in ancient Greece mostly consisted of scattered propositions and empirical summaries. For example, Pythagoras discovered the Pythagorean theorem but did not form a complete proof system. Euclid was the first to propose the idea of axiomatization, first establishing basic axioms that require no proof, then deriving all relevant theorems through strict logical reasoning. The advantage of this method is that as long as the axioms are correct and the deduction process is error-free, the conclusions must hold, thus ensuring the reliability of knowledge. This deductive reasoning from general to specific echoed Aristotle's logic, jointly shaping the rational tradition of Western science. Euclid also emphasized the research methods of abstraction and idealization. In Elements, the points, lines, and planes he defined are not specific objects in reality. A point is that which has no part, and a line is breadthless length. These abstract concepts break away from the limitations of real objects, allowing geometric research to focus on essential laws. For example, Straight lines in reality always have thickness. But Euclid's straight line is an idealized mathematical model. It is this abstract thinking that enables geometry to be applied in architecture, astronomy, mechanics, and other fields, becoming a tool to solve practical problems. More importantly, Euclid's ideas contain the purity of the pursuit of truth. He did not pursue the practical value of mathematics, but firmly believed that mathematics is the key to understanding the order of the universe. In his view, geometric laws exist not only on paper, but also in the movement of stars, architectural structures, and natural phenomena. This idea of explaining nature through mathematics influenced later scientists such as Copernicus, Kepler, and Newton, promoting the birth of modern science.